This is chapter 9a, Introduction to Hypothesis Testing. So we start off with an example. Suppose we are interested in determining if a majority of adults favor this idea of lowering the legal limit for blood alcohol concentration that determines if you're driving drunk. So we start off with just this idea that I'm interested in seeing if my hypothesis is correct. Okay, we're going to use the word hypothesis here in the English instead of the word I'm hypothesizing something. And a hypothesis test is simply trying to determine if this hypothesis that you have is correct or incorrect. Okay, so just again, a lot of basic English usage of these words. And so how are we going to do that? Well, as we've talked about in the entirety of this course, we're going to say, I'd like to know something about this parameter. It's hard to do that for time or cost reasons. And so I'm going to take a sample and I'm going to use that to make an inference on that parameter. And that's what we're going to do here. We're going to say the parameter is, do all of the adults in the district favor the proposal or not? So notice we didn't use the word all, but that's what's implied here. A legislator wants to determine whether a majority of adults in her district or whether a majority of all the adults in her district. Okay, so again, we're just kind of making sure we understand the context of what we're talking about here. And we're trying to figure out how does everyone feel, but again, we can't really ask everyone because people move in and out all the time. People are out of town or at work, won't pick up their phone. You couldn't go door to door. Like it just would be infeasible, right? So what are we going to do? We're going to take a sample and we're going to use that to make the inference on the overall population. So we're going to survey 200 randomly selected people, and we find that 59% favor the proposal. And as we talked about, this is the sample information that we're going to use to decide if more than 50% in the district actually favor the proposal. Can we conclude we have a majority in support? And this is where I want to make sure you understand why we're doing a hypothesis test, because this comes up in the real world often. When you take a sample, those sample results will say something. And you have to be careful to not just take those sample results and say, oh, that's the truth, because it may be and it may not be. And that's what I finish off this example by saying here. Because the result is based on a sample, there's possibility that the majority may have just occurred by luck of the draw. And so we have to make sure we understand that when we get sample data, that is my best guess at what the truth is, but I want to dive deeper and not just say, yes, I think that 59% do favor this proposal, but say, well, what if a majority don't actually approve? How likely is it that we would have gotten results like we did? How likely is it that 59% would actually favor it if the truth is actually less than half? And so this is the basic framework of a hypothesis test, is saying, what if my hypothesis is correct? What's the likelihood that we would have gotten data like we got just by chance? And if we say, hey, it's not very likely that it happened by chance, that leads us down one path. If we say, no, this could have easily happened by chance, that leads us down another path. And that's what I want to have you write down here, this concept of a hypothesis test. We test a claim by analyzing sample data in an attempt to distinguish between results that could easily occur by chance and those that cannot. That's very important, that phrase right there. You need to know that phrase. I'm not going to test you if you've memorized that phrase, but if you know that phrase and understand that's what the idea of what we're doing here is, it will help you out understand why we're doing what we're doing and make all of this make a lot more sense. Okay, we are going to work a hypothesis test and we're trying to figure out, hey, this sample data that we got, could it have happened by chance or not? And if we say that it probably could not have happened by chance, as in something that was unlikely to have happened by chance, these unlikely results, then we're going to say that my underlying assumption is incorrect. This is the framework of a hypothesis test in a nutshell. We're going to make an initial underlying assumption, And then we're going to test that claim to see, could this have happened by chance? And if we say this could not have happened by chance, we're going to come back and say, you know what, that initial assumption I made, that was probably wrong. Now, side note, we don't ever know if it really was wrong. We're just going to say we're gonna act like it's wrong. We're gonna conclude it's wrong because we have to make a decision, right? And we're gonna go back and we're gonna say this seems very unlikely. My only logical conclusion is that the underlying assumption is incorrect, right? And we're gonna liken this to a jury case later, and it's that same concept there that when a jury deliberates on information and they say, this isn't adding up, I think this person's guilty. They never really actually know, but they're going to say, you know what, this whole we assume this person was innocent, I just can't buy that. I'm going to conclude he's guilty because that's really the only thing I'm left to do with this evidence to the contrary of my initial assumption. And that's this idea here. When we have highly unlikely results, we're going to say that initial underlying assumption was probably not right. So a couple key terms here. Hypothesis test, we've already kind of defined it. It's a procedure for testing a hypothesis, right? We're going to say, I have a hypothesis. Now we're going to use the sample data, that's the mathematical part of it, in order to determine were my results likely or not. A statistical hypothesis specifically is a claim or a statement about a parameter, and the key word in that statement is parameter. If you are writing out your hypotheses, we'll talk shortly about the null and the alternative, but your hypotheses, both of them need to have parameters and only parameters in them. If you have statistics in them, you're illustrating that you've missed the boat completely. I would never hypothesize about a statistic. Why is that? A statistic comes from a sample. I don't have to hypothesize, I know. Does that make sense? Like, I don't have to a hypothesis is a guess. It's an educated guess, right? I don't have to guess on something that I know. A statistic literally is what it is. When I go take a sample of 200 people and I get data from that, I have the actual data. There is no guesswork involved. So I would never hypothesize about X bar or S or P hat or any other statistic that we want to come up with because I know what my statistics are. We hypothesize about our parameters. Why? Let's go back to that phrase I've been saying all along. We don't know the truth about the parameter. We have to use the data to make an inference on it, right? The parameter is this unknown quantity, right, that I can't figure out. And so I would make a hypothesis about a parameter. Okay. We have two hypotheses, the null and the alternative. The null hypothesis is a statement of equality. Highlight that right there, equality. The null hypothesis will always have some form of an equals in it. It will either have just straight equal to, or it will have greater than or equal to, or it'll have less than or equal to. And we test the null hypothesis directly in that we assume it is true. That's another thing to highlight. We always assume the null hypothesis is true when we work out our hypothesis test. We're going to start off by finding our null and alternative hypothesis, and we're going to say, okay, this null hypothesis, we're going to assume this is true, and we're going to work all of our math based on that assumption. Just like in a jury trial, we assume the person's innocent. That's how we start off. Now, at the end, we may change our mind, but we start off with saying we're going to assume that person's innocent. We're going to start off with this null hypothesis. We're going to assume whatever it happens to be, whatever parameter is in the null hypothesis, we're going to assume that whatever statement that is, that it's true, and then we're going to reach a conclusion about its validity. And what I mean by that is we're directly testing the null. Okay, so we're going to come back and we're going to say, I think the null is right, or I think the null is wrong. We're going to directly test the null. We're going to assume it's true, and we're going to come back and we're going to say we either think it's right or we think it's wrong. Okay. And its notation is, we call this H naught. It's an H with a 0 subscript. And then the alternative is a statement of inequality. So highlight your circle or whatever the inequality part. There will be no form of an equal in the alternative. It will be a not equal sign, it will be a greater than, or it will be a less than. It will not have any form of an equal in the alternative hypothesis, and it is tested indirectly in that we reach our conclusion about it based off what the null is. Okay, so we are going to determine what we think about the null, and then the answer to what we think about the alternative is just based off of what happened with the null. Okay, so we're kind of building this framework of hypothesis testing. We're going to start off with our two hypotheses, the null and the alternative. We're going to do some math. We'll cover that as we move forward. and we're going to reach a conclusion about the null, and then whatever we decide about the null, that tells us what we think about the alternative. It's a one-to-one correlation there. You do not ever reach a wonky conclusion about the alternative, because your conclusion about the alternative is always based on what you said about the null. If you say A about the null, you have to say what follows along with that about the alternative. And if you say B about the null, you have to say what follows along with that for the alternative. Okay, and I put here in parentheses research hypothesis. That's another term you may hear rather than calling it the alternative, and it is denoted by H1. Some places put HA for alternative. Either notation is fine, not a big